So let's see how these identities work in actual practice. The idea here is to start off by rewriting the trig expression by doubling the given angle. So, for example, if we take 112.5, this is not an angle that I'm familiar with on the unit circle, but if I take 112.5 and I double it, then I get 225, which is an angle that I'm familiar with. Okay, so that means that if I take, I'm not going to take the cosine of 225, but I'm going to take the cosine of 225 over 2 degrees, right? Because 225 over 2 is the same thing as 112.5. Okay, so what we now need to do is determine the quadrant that our angle lies in so that we can determine the sign of our answer. Do not look at the 225 for this. We are not taking the cosine of 225, we are taking the cosine of 112.5. This is a quadrant 2 angle, which means that the cosine is going to be negative. Okay? Cosine is negative in quadrant 2. So that means that when we apply this identity, we don't want plus or minus. We're going to pick minus, and then we're going to substitute the angle into the value, into the right identity. The cosine half angle identity has the plus inside the square root, right? The cosine, and this time we're not using 112.5. The whole point is that we can deal with this 225. 225 is an angle that we have memorized from the unit circle, all over 2. And I'm realizing I might have skipped number 3 here. They wanted us to put the theta here and then replace the theta with the 225. So sorry, I skipped step 3. But anyway, when we finish this up, we say, well, actually, I can evaluate this now. I'm going to go over here to have a little bit of room to simplify. But we've got this negative the square root of 1 plus the cosine of 225. Well, 225 is that angle that's, I guess, the 45 degrees in quadrant 3, right? It's going to be over here. So when we take the cosine of that, we're going to get negative root 2 over 2. So that's going to be what goes right here, negative root 2 over 2. And then we'll divide that by 2. All right, that's our answer. We don't like to leave it like that because it's too messy. So we'll multiply that fraction, top and the bottom, by 2, right, inside the square root. And we're allowed to do that. This orange thing is equal to 1, so we're just multiplying by 1. And that means that when we distribute that, we get the square root of 2 minus root 2 over 2 times 2 is 4. All right, and then one more step here. We're taking the square root of a fraction, which means the square root of the top. So the square root of 2 minus root 2 divided by, and then the square root of 4 is just 2. So what a pleasing answer, right? It's all 2's, and there's lots of square roots, nested square roots. It's kind of an interesting looking answer, but the cosine of 112.5 degrees is this value right here. Okay, so that's pretty much how all of these are going to work. For this one, we're going to say, well, let's take a look at multiplying 17 pi over 12 times 2. That's going to give us 17 pi over 6. Okay, so this is the same thing as taking the sine of 17 pi over 6 divided by 2, right? We get that 17 pi over 6 by doubling the given angle. So we're going to take the sine of half of this angle. That's why it's the half angle identity. All right, 17 pi over 12 is the angle we are taking the sine of. 17 pi over 12 is in quadrant 3, right? It's a little bit bigger than 12 pi over 12. It's a little bit smaller than 18 pi over 12. So it's going to be in quadrant 3. You know, it might help if you do this with the 0 and the pi, but if we want to make this, and then this is 2 pi, if we wanted to make this out of 12, then we would say, oh, that's actually 12 pi over 12. And this is half of 12 is 6. Ooh, that's not a 6. 6 pi over 12. And then 6 plus 6 is 12. 12 plus 6 is 18. So 18 pi over 12. So we know that 17 pi over 12 is going off in that direction. So we would then realize that sine of a quadrant 3 angle means that our answer is going to be negative, right? And we'll have the square root of, let's see, this one's going to be a minus because the sine formula uses a minus, and we'll take cosine because whether you're dealing with sine or cosine, the cosine function is going to be inside there. Remember, that's because both of these formulas were derived from the double angle identities. And here we don't put in our original angle. The whole point is we're going to deal with one that we know how to work with, 17 pi over 6. Okay? Well, 17 pi over 6 is a little bit too big for my taste, right? It's bigger than 2 pi. But we can find a coterminal angle to 17 pi over 6 by subtracting 2 pi, which is the same thing as 12 pi over 6. 17 minus 12 is 5. Aha! 5 pi over 6 is a nice angle. I can deal with that. So we're going to do negative the square root of 1 minus whatever it is that the cosine of 5 pi over 6 is. Well, cosine of 5 pi over 6 is negative root 3 over 2. All over 2. So when we simplify that, we'll get negative the square root of, let's go ahead and do that same trick where we multiply the top and the bottom by 2 inside the square root. So that means that we'll get 2 in the numerator. Minus a negative is plus. The 2's cancel out, and we get the square root of 3 divided by 4. And the same deal with the square root of 4 in the denominator. We can turn that into a 2. So we get the answer of negative the square root of 2 plus root 3 over 2. And that negative just reminded me that it looks like I lost my negative over here. I wonder how many of you guys were shouting at the screen, Mr. Pomerantz, you forgot something. Yeah, I forgot the minus sign here, didn't I? Oops. That's an easy thing to do, isn't it? So you got to be awake for those. All right. One thing I'll say about this one before we try the tangent formula is notice that we could have very easily had done a sum identity here instead. We could have said, oh, well, actually, I know that 17, I don't know where to write this. Maybe I'll write it over here. I know that 17 pi over 12 is the same thing as, oh, I don't know, 4 pi over 12 plus 17 minus 4. Oh, wait, that's not a good one. Maybe we'll try 3. Let's do 3 pi over 12 plus 17 minus 3 is 14 pi over 12. And this reduces to pi over 4. And this reduces to 7 pi over 6. So if you had chosen to do the sum formula for the sine, that should give you the correct answer as well. Interestingly, it's not going to look the same as this. We've done these sorts of problems before, and we've never really seen that nested square root, right? We haven't had a square root inside of a square root before. But turns out the answer you get from using the sum identity and the half angle identity, while they look different, are actually numerically the same thing. So I invite you to explore that a little bit and play around with it, because it's kind of neat. It's not that one is better than the other, they're just different, but they are equivalent. Alrighty, so let's try that tangent problem. Let's do, the idea here is that a denominator of 8 we don't like, but if we multiply this by 2 and get 7 pi over 4, well, we do know how to do that one, right? The tangent of 7 pi over 4 divided by 2 is the same thing as the tangent of 7 pi over 8. So we're dealing with half of an angle that we know how to work with, right? So again, actually, we don't have to worry about the pluses and the minuses on tangent, provided we use those identities that don't use the square root. So when you can avoid it, let's avoid that plus or minus business. So I like to use the 1 minus the cosine for the numerator and then the sine on the denominator, because then we keep our denominator simpler. So 7 pi over 4 is our theta value our theta over 2 value that we care about is 7 pi over 8, but we're going to do the work with the 7 pi over 4. And the cosine of 7 pi over 4 is root 2 over 2. The sine of 7 pi over 4 is negative root 2 over 2. So when you multiply by 2 over 2, you end up with 2 minus root 2 divided by negative root 2. Okay? So, yeah, that's right, but maybe we'll go ahead and rationalize this, because I think nice things happen when you rationalize this. So if you multiply the top by root 2 and the bottom by root 2, we'll go ahead and do a negative, so we don't have to deal with that extra negative down there. You could deal with it now or later. Negative 2 root 2 is the first term in the numerator. Positive 2, right, is the second term in the numerator. And then in the bottominator, we get negative root 2 times negative root 2 is a positive 2. Why is that better? Because we've got a common factor of 2 in both terms in the numerator. So we'll divide that by 2 and we'll get negative root 2 plus 1. Or perhaps more pleasingly, 1 minus root 2. Either one of those is good. So those will be your double angle identities at work. So either one of these is good for your final answer for this. This is good for your final answer for the example 2. And this one with that negative that we almost forgot is good for your answer for number 1.